In this session, we will see about an deletion operation. In the last session, we have seen a single linked list insertion operation. In the insertion, we have performed insertion begin, end, and specific position. So here in this session, we'll perform deletion with the same three scenarios: deletion begin, and deletion at end, and deletion at specific position. So now deletion at begin, simple one. So now what I have to do? The head is 500 over here. That's the first node. What's a head node? Head node always points to the first node. So now if I want to put deletion at the first node, okay, simple. The head node should change to the second node. That's it. So now how can I change this head value? The second node address is available in this position. So head is equal to head of pointer. So head is this node and head of pointer is 1000. 1000 is assigned to the head. If I do it so, then the link is created from the head to the 1000th node. Then I can free this memory space. To free the memory space, then I need to store this address in some variable. So then we can declare some variable and then I can free the memory space. Okay. So now for this logic, we'll perform program. So we need a local variable because I need to store in corresponding the deletion node address then to free the memory space. And then I'm assigned temp is equal to head. So now here in this scenario, our temp value becomes temp value is equal to 500 in our case. So and then so to delete it, head is equal to head of pointer. So now what happens over here? Head is equal to head of pointer. What's head value? Head value is 500. So 500 of pointer is 1000. So 1000 is assigned to the head. So head is equal to 1000. Head is equal to 1000. So now what happens over here? The head has been changed to the 1000. So the link is broken and this link is created to the second node. Okay. So now what do we do it over here? I will free the memory space. I'll free the memory space. So temp is 500, right? This node memory space should be freed up. So once I free the memory space, then the corresponding node has been deleted. The link is deleted. So once I free the memory space, the memory space has been freed up. Okay. So this is the performation of operation of deletion at begin. So now next scenario, we'll perform deletion at end. Deletion at end. So to perform deletion at end, I should go to the last node. Okay, so should I go to the last node or last previous node? Last previous node. Okay, so simple one. I will go to the last previous node and then I will change to the corresponding this position to the 0. So now we will see delete from delete at end. So we need a local pointer temp, and then I need one more pointer called an and previous node. I will tell the reason why do I require. So initially I will assign the temp is equal to head. So temp value is 1000 here. Temp is assigned to the head. So temp value is 1000. Suppose if we have only one node, in the linked list, okay. So then what happens over here? The one node also should be get deleted. So if at first I will go to the last node. So until temp of pointer is not equal to 0, I will keep on traversing. So once I keep on traversing, then what happen over here? I will keep on updating value of temp. I will keep on updating value of temp for traversing purpose. So already we have known this. So while temp of pointer is not equal to 0, here I am going to store the previous node address in the previous node variable. So previous node temp is stored over here. So in our case, in the previous node now value is 1000. Previous node value is 1000. Okay. So previous node value is 1000 over here. Then I will update the value of temp. Temp will traverse to the next node. So temp is equal to temp of pointer. So now here what happens over here? The temp value becomes temp is equal to temp of pointer. Temp is 1000 over here. So 1000 of pointer is 2000. So temp will be equal to 2000 over here. Okay. So now what do we do? What do we check? It's now if suppose for example, is it an correspondingly temp is 0 or not? It's not 0. Okay. So now what do we do? I'll be keep on traversing. I'll be keep on checking once again. I'll be keep on checking once again, once again, once again. Okay. So then so we have gone to the last node. Okay. So then what I can do it over here, I can change the previous node. What's the previous node? So as I keep on traversing, the previous node value will becomes I will take this as a previous node temp is equal to temp of pointer. The temp will be equal to 3000 and this node will be 2000. Okay, so at last, after the whole iteration, the previous node means what? The last node before node. This node address is 2000 and then temp is equal temp of pointer 3000. This is after full iteration. Okay, so once the temp of pointer will be equal to 0, this is the value. This is the value. So now what do I do over here? I will go and change the previous node of pointer position to the 0. What's the previous node? 2000 of pointer position to the 0 and then I'll free the temporary memory space. I'll free the temporary memory space. This is the logic. Okay, so now once it is done, I will go the previous node. I'll go to the previous node of pointer position and then I'll update it to the corresponding 0. Then I'll free the temporary memory space. So this is the operation of deletion at end. In next section, we will see that deletion at specific position. Okay. Thank you.